So let's just start with the vibe check problem. You get an output from an LLM, you read it, and you kind of nod. It feels right. But if you're deploying a RAG system for a bank or, I don't know, summarizing legal briefs, vibes just don't pass a unit test.
And vibes definitely don't scale. You can't vibe check a million documents,
Exactly. And that is the core of our deep dive today, LLM evaluation. We're pulling from a stack that includes some great research from Stanford's Foundation Model Group, technical guides from Arise AI and Confident AI, and the latest data on benchmarks like MMLU.
And the mission here is to really uncover how we engineer a unit test for intelligence. Because the old methods are, well, they're failing. And the new ones are getting a little circular.
Yeah, let's quickly bury the old world metrics. I mean, anyone still relying on BLEU or Rouge for generative tasks is essentially flying blind at this point.
Oh, completely. They're obsolete because they're just so rigid. They measure n-gram overlap, which is just literal word matching.
Right.
So if your model writes a brilliant, totally novel summary, but it doesn't match the reference text word for word, ROs just fails it. It actually penalizes creativity. It can't capture semantic meaning at all.
So the industry pivoted to standardized testing, the MMLU, Massive Multitask Language Understanding. For a while, that's been the gold standard, right? It covers 57 subjects, everything from math to virology.
It was, but looking at the Stanford data, its utility is really starting to plateau. The big problem is data contamination.
Okay.
These models are trained on, well, the entire internet. So there's a statistically high probability they've already seen the test questions and the answers in their training data.
So we aren't testing reasoning. We're testing retrieval.
It's memorization. And frankly, the benchmark itself is flawed. Researchers found up to 6.5% errors in the MMLU answer Ps in some parts. So we're basically measuring these models against a crooked ruler.
Which forces the shift toward LM as a judge, which I thought was the most compelling part of the Arise AI notes. We're not writing code to test the model anymore.
No. We're using a stronger model, like GPT-4, to grade the weaker ones.
Wild.
Yeah, it's the current state of the art. Specifically using frameworks like GVAL, it uses what's called chain of thought reasoning.
So instead of just asking, is this summary good?
Right. GEVAL forces the judge model to generate evaluation steps. It has to think through the criteria before it assigns a score.
And the research shows this actually aligns much higher with what humans prefer than any old code-based metric.
Yeah.
But for people building RGA systems, general scoring isn't enough, is it? You need specifics.
You have to decouple the failure points. Arise breaks this down into two really critical buckets, faithfulness and answer relevancy.
Faithfulness being, did the model just make something up? Did it hallucinate something that wasn't in the source text?
Exactly. And answer relevancy is, did it actually address the user's prompt? A model can be faithfully hallucinatory.
Or completely irrelevant but factually true.
Right. You need to catch those distinctions automatically.
Now, automated judges are fast, but we still need to know if they align with reality. And that's where the chatbot arena methodology comes in. It's like an ELO rating system for LLMs based on blind human voting.
It's the gladiator pit approach. It captures that nuance of human preference that an automated metric might miss. But even that has a risk. If everyone just chases the leaderboard, you succumb to Goodhart's law.
When a measure becomes a target, it ceases to be a good measure.
Precisely. If you optimize purely for the arena, or MMLU, you create a fragile model. And that's why Stanford's HELM project holistic evaluation of language models is so vital.
They don't just measure accuracy.
No, they track toxicity, copyright infringement, bias, across dozens of metrics.
It forces you to look at the trade-offs. You might have the smartest model, but if it's constantly triggering copyright filters or spewing toxic content, it's a liability, not an asset.
It moves us from simple accuracy to a more complex and I think more important view of behavioral safety.
You know, it really feels like we're entering a recursive loop, though. We use AI to write code, and now we're using AI to judge if that code is any good because the volume is just too high for humans to review.
It is the Ouroboros, the snake eating its own tail. We're increasingly relying on synthetic intelligence to verify synthetic intelligence.
Which leaves us with a provocative thought to wrap up. If we outsource the definition of quality and even truth to the models themselves, at what point do we lose the ability to recognize it on our own? Thanks for listening to The Deep Dive.